This week has been huge for AI models as we got three new models from three different providers. DeepSeek released V4 Pro, Google released Gemini 3.7 Flash, and XAI released Grok 4.6. And normally, when three models launch in the same week, every company will obviously tell you that their model is faster, smarter, cheaper, and probably capable of solving all your agent requirements. But for us developers, the actual question is much simpler. What is actually new in these models? Where do they sit compared to other frontier models? And if I'm building an agent today, which model actually makes sense? So let's go one by one. So DeepSeek first introduced the V4 family in April, but on August 13, they released the proper V4 Pro flagship. Now on paper, this is a massive model. V4 Pro has around 1.6 trillion total parameters, but it is a mixture of expert models, so only a much smaller part of that network is active for each token. So very roughly the model in total has 1.6 total parameters. The router selects the relevant expert and only 49 billion neural nets get active per token. So instead of running the complete gigantic network every time, different experts get activated depending on the token. But the more interesting thing for you and me is not the 1 million token context window, but how DeepSeek is trying to make the context cheaper to serve. Normally, in a transformer, as context gets larger, attention becomes increasingly expensive because the model has to deal with relationships across a huge number of tokens. So, DeepSeek's V4 family uses something called DeepSeek Sparse Attention. The simple idea is that if I give the model 1 million tokens, not every token should need the same amount of attention at every step. So instead of treating the entire context equally, the architecture try to compress and selectively attend to the useful parts. And this is actually important because now 1 million token context itself is not very unique. Claude, GPT, and Gemini are also operating around this range. The difficult problem is now how cheaply can you actually use that context? Now you might ask, where does DeepSeek sit? So the new V4 Pro is much more stronger than the V4 Flash on independent intelligence evaluations, but I would not say it suddenly destroys all frontier models. And that last part is important. DeepSeek is still open weight, so unlike GPT, Claude, Gemini, or Grok, companies can actually host and build around the weights themselves. Now, pricing is where it gets very uncomfortable for the closed providers. The August V4 Pro launch pricing is roughly 435 cents per million input tokens and 87 cents per million output tokens. Then one day before DeepSeek on August 14, we got Grok 4.6. Now, Grok 4.5 was already interesting because it was not necessarily winning every coding benchmark, but it was doing strong agentic work while using fewer output tokens and fewer steps than some much more expensive models. Grok 4.6 basically pushes that position further. The earlier independent reporting puts it around 5 intelligence index points above Grok 4.5, roughly bringing it into GPT 5.6 soul territory on the overall index, while still costing around $2 per million input tokens and $6 per million output tokens. Now compare that to premium frontier pricing where outputs can be $25, $30, or even $50 per million tokens. So Grok's argument is not simply that it is cheap. The actual part is cost per completed task. So let us say one model charges $3 per million output tokens but takes 100,000 tokens and several retries to solve your coding task. Another charges $6 but solves it in 20,000 tokens. The second model can still be cheaper in practice. And this becomes especially important for agents because agents do not make one model call. They can make dozens or hundreds. And there is also an interesting side of the story which I think is more interesting for developers. So we all know Cursor jointly trained Grok 4.5 with XAI, and Cursor says that training included trillions of tokens of Cursor data, showing how developers interact with repos, tools, and coding agents. Recent reporting also says Cursor helped train Grok 4.6 as well. So the model has been trained around the type of environment in which cursor will actually run it. So optimization happened at two levels. Model level, learn how coding agents use tools and work across repositories. Then harness level, cursor decides what context to provide, which tools are available, how the agent executes them, verify, and continue the task. So this basically is model plus harness code design, and it is one of the reason I would evaluate Grok inside cursor separately from evaluating Grok through a raw API call. Also at Cursor Bench, we can see that Grok 4.6 has a score of 70.8%. The cost per task value was $2.81, and the tokens per task taken was 41,136 tokens, and steps taken was 46 steps. Now compare that to something like Fable 5, and which is very curious as Grok exceeded the score while completing the work with fewer steps and a much more lower estimated model cost. Cursor also changes this pricing. So if you call Grok directly through the model API, a simple number is still roughly $2 per input token and $6 per million output tokens. But inside Cursor, the economics are slightly different because Grok is treated as part of Cursor's first party model family. Cursor's paid individual plan currently advertises generous Grok and Composer usage inside the subscription. The normal Pro plan is around $20 per month. And no, that does not mean Grok becomes free inside Cursor. Expensive or very long requests still consume your included usage faster because the pool is ultimately tied to model token economics. But if you are already paying for Cursor, Grok can be economically more attractive than opening a separate XAI account and paying every API token from the first request. For India, there is also a Cursor Start, which starts at 649 rupees per month, which explicitly includes generous access to Grok 4.5 and Composer. So, Grok 4.6 is currently interesting if you care about long running coding agents and frontierish capabilities without premium model economics. And inside Cursor, the story becomes even more specific. This is increasingly a model trained with the environment it is going to operate inside, rather than just another third party model plugged into an editor. Then on August 13, Google released Gemini 3. Flash only a few weeks after 3.6 Flash. And I think Gemini is slightly different from the other two because Flash is not trying to be Google's absolute maximum intelligence model. The whole point of Flash is, can this be the model that I can afford to call again and again inside a production agent? And Google has been optimizing Flash around things like fewer unnecessary reasoning steps, fewer tool loops, better multi step planning, better coding, and lower output token usage. This direction already started with Gemini 3.6, where Google reported lower reasoning output token usage than 3.5 Flash on several agent workloads. And 3.7 continues in that direction and is specifically being positioned for coding and automated business workflows. So, reducing even one or two unnecessary reasoning or tool loops starts saving a lot once the workflow runs thousands of times. And Google has already another advantage here. Gemini is already deeply multimodal, so one model family can work across text, images, PDFs, audio, video, code, and tools, which makes Flash especially useful when the agent is not purely a coding agent. The early launch positioning also makes 3.7 cost same as the previous Flash tier. So there is no price hike as well. So Gemini's story is basically, can we move enough frontier capabilities into a Flash model that developers simply use it everywhere? So how do these compare with the actual frontier models? Now, let us put them beside the models developers are already using. The first thing, I would not compare a DeepSeek model directly with the most expensive Claude model and say DeepSeek is 100 times cheaper. Obviously, it is cheaper. They are not targeting the same operating point. And look at the current API economics. Now, this table explains why these releases matter. So, the capability difference between a $4 and $6 output model and a $25 to $30 output model is not 5 or 6 times on every workload. For some difficult tasks, yes, paying for the flagship can absolutely be justified, but for a production agent running thousands of tasks, the right question becomes, what is the cheapest model that crosses my reliability threshold? So, what is actually new and what is the hype? If I remove the model company marketing, I think there are four actual changes happening. 1 million token context is becoming normal. DeepSeek, Gemini, GPT, and Claude are all moving around huge context window. So context size itself is slowly becoming less interesting. The new problem is, can you use that context cheaply and actually retrieve the useful information from it? That is why DeepSeek's DSA is more interesting to me. Agent efficiency is becoming a first class feature. Google is already talking about fewer tools and reasoning loops. Grok is competing heavily on token per completed engineering task. OpenAI itself talks about performance per dollar and programmatic tool calling. So the industry is slowly moving from benchmark score to successful task plus total cost. That is much more useful matrix for builders. And then models are becoming more agent native. So OpenAI now lets 5.6 use programmatic tool calling, where instead of calling one tool, returning to the model, then calling another tool, the model can write a small program to coordinate tools and processes intermediate results. This is interesting because it is the exact same broader direction we are seeing in modern agent harnesses. Do more work programmatically outside the root model instead of stuffing every intermediate result back into the context. Also, cheap models are becoming genuinely useful, not just routers. A year ago, a cheap model was something you used for classification, routing, or maybe extracting JSON. Now, Flash, DeepSeek, and cheaper GPT tiers can legitimately run multi step coding and agent workflows, and that is probably the biggest change. So, which model should a developer actually use? If I had to simplify this today, DeepSeek V4 Pro, use it when you care about open weights, long context, and aggressive cost. If you are building infrastructure around your own model stack or simply want very capable inference without frontier pricing, DeepSeek is extremely hard to ignore. Grok 4.6, use it when you care about coding, agents, long running tool use, and strong capabilities per dollar. If you already work inside Cursor, I would test Grok there first because Cursor has been directly involved in training the Grok and bundles substantial Grok usage into its paid plans. That gives you a different model plus harness plus pricing evaluation than simply calling the raw XAI API. Gemini 3. Flash, use it when you care about high volume production agents, multimodality, and Google's ecosystem tool workflow. Flash makes the most sense when the model can be called constantly rather than only for the hardest 1% of the task. And then premium Claude GPT frontier model. Still use them when failure is expensive and maximum capability is actually worth paying for. The mistake would be using the most expensive model for every single step simply because it has the highest benchmark score. A good production architecture may actually look like cheap models to classify, inspect, and perform routing work, strong mid-tier models for most agent tasks, and frontier flagships only for difficult evaluations. And this is probably where model routing is going. So, the interesting thing about this week's release is not that DeepSeek, Grok, and Gemini suddenly killed GPT or Claude. They did not. The interesting thing is that the pricing performance gap is collapsing extremely quickly. DeepSeek is asking how close an open model can get to frontier capabilities while staying dramatically cheaper. Grok is pushing frontier intelligence towards much better agent economics. Gemini is trying to make Flash strong enough that it becomes the model you can simply run everywhere. And for developers, I think this changes how we should choose models. Instead of asking which model is the smartest, the better question now is, What is the cheapest model that can reliably complete this particular task? Because when you are building agents, a 3% benchmark advantage means very little if the model costs 5 times more and you are calling it 100 times. And I think that is the real story behind these three releases.